Well, good morning, everyone. It's almost a minute to 10 a.m. Thank you very much for joining us for our virtual crop hour this morning. We're going to have two talks. The first talk will be on soil fertility and how that is important in wheat production. We all know the importance of soil fertility. Weak plants are going to be susceptible to diseases and other problems, and of course, they will yield badly. And of course, in wheat, we know that soil fertility also affects protein content. So a great talk today. And then after the first talk, we'll have a talk on selecting the best wheat variety. So great talks this morning. So thanks for joining us. And we'll start with the first talk. And after the first talk, I will put up the QR code for those people who need the CEU units. I will do the same also after the second talk. You can use the chat box or the Q&A area to type a question anytime, and those questions will be answered after each talk. And after the two talks, we'll have a continued discussion on the presentations or any questions you may have on wheat production. So without a lot of time that I'm taking off, we'll start with the first talk on soil fertility in wheat production given by Anthony Bly. Anthony has been with SDSU for a long time, great experience working on soil fertility. And of course, he's a farmer himself, so it really helps a lot. And so he brings a lot of experience to the extension. So without further ado, Anthony, over to you.
Thank you, Emmanuel, for your very nice comments. I'll get this going here. Okay, thank you, Emmanuel. Yeah, thanks for attending this morning. You know, I really got to start out by giving a lot of credit to my predecessors, and of course we have Dr. Jason Clark that replaced Ron Gelderman. I worked with Ron for a long time, and Howard Woodard and Jim Gerwing. We had a really good run together as a team, and there's other folks involved as well that worked in the soil lab. But what a great run! Fond memories of that time. So why are we talking about wheat in the rotation? You know, with corn and soybeans today, wheat's up there in price too. But boy, you know, I saw $13 soybeans yesterday. You know, almost $5 corn. Why would we think about growing wheat? Well, you know, it's very important to have a crop rotation, and wheat is an excellent crop for that. It breaks those pest cycles. You've heard our pest experts speak about those. Provides diversity in the soil. The microorganisms need that diversity. We're hearing a lot of talk about soil health and regenerative ag. Those are very important topics. Our non-ag folks in society hear those terms, regenerative ag and soil health. And it's just not exclusive to agriculture. So we need to focus on those and have discussions about those at other times. But it also provides a different root system compared to soybeans, which is a taproot, and corn, which is also a fibrous root, but it's a more of a deep fibrous root. And we grow those in, you know, 30-inch corn in rows, 30-inch rows, where wheat is more of a well-dispersed fibrous root crop. And so it has something different to offer as far as roots go. Provides a great opportunity to include a cover crop, which provides another set of, you know, benefits as well that include the soil biology diversity, and then soil aggregation, forming those aggregates so that we can have good water and air infiltration in and out of our soil. So most growers that I know that include wheat in their rotation say one thing. You know, wheat has not been generally a big moneymaker, but it really enhances the yield of their corn and their soybeans. And I think that's so important to recognize that following a good rotation, it has a lot of benefits. So, you know, I'm going to show you some soybean yields here. My intent was to build up on that notion of the fact that wheat is a good rotational crop, and the more rotation we have, the better. And soybeans respond to that. And here's a summary of a literature search. And you know, there's a lot of papers I read just to get this data from that. So it's kind of like a meta-analysis. But if we see, I made a table to explain all of that. And so if we look at this graph, we have years across the bottom. So number of years of soybeans in a row. So the one there represents years, at least 2 years without soybeans in the rotation. So it'd be like growing soybeans after wheat, which was planted after corn, or vice versa, or something like that. And then the 100 line is the corn and soybean yield. I use that as a benchmark. Okay, so that number one there, if you've grown soybeans at least 2 years prior, or out 2 years without soybeans, you see a slight yield increase of about 6%. So that's something to hang our hat on for sure. And then if you grow soybeans 2 years in a row, we see a yield decline of about 5%. And then 3 years, it drops another 5%. And then 4 years down to about 13% reduction. So wheat is a very, very good placeholder in our rotation, and we know how to grow it, and there's a lot of information about it. And one of those studies that I was involved with, you can see started here in 1991. If you look at the figure caption down below, and ran until 2010. And it's the calibration work that we do. And it was a site that had all three crops. And I just want to focus on the wheat, of course, here today. But those are the orange circles. And we can see a lot of responses occurring here in this area. Anything below 100 would be a response to phosphorus. And they are all occurring mainly below that 12 part per million soil test level. So this is how we get our recommendations. We do a lot of work like that, just not that one. A lot of work by a lot of people have been done to develop this table. And so what we have here is we have soil test phosphorus, what I want to talk about, and then the categories for that, very low to very high. We have the Bray test that you may run on your lower pH soils. And then we have the Olson test that we kind of recommend for all the soils in South Dakota. And then yield goal over here. It's very important to know your yield goal. And I talked about that on Tuesday in the Southeast Farm annual meeting, and I won't today, or I might, I'm sorry. Anyway, but it's reflecting yield goal here. As yields go up, the yield goal goes up, so does the phosphorus recommendation. And as soil test goes up, the phosphorus recommendation goes down, and we have a point where it's 0. And we would not recommend any phosphorus at this point. Actually, if you're above these two sufficiency levels, we'd recommend that you'd actually mine that phosphorus back down, and that you use soil testing to monitor that and keep it right. Actually, we want you to keep it right in this high category, right around in there. So that's why we would recommend that you don't apply any, and that's so important when margins are tight and you need to find a way to make money. This is where you go to do it, and so soil testing is a very valuable practice. And then I have soil test potassium here. I'm not going to show you any graphs today about that, but same kind of thing, very low to very high. And as yield goal goes up, our recommendation goes up, and as soil test goes up, our recommendation goes down. So same kind of theory. And here are the equations, and these can all be found on our extension website. Dr. Clark has put up our recommendations in a digital format now, so you can search those out. So here is the yield goal I was talking about. The amount of nitrogen to apply, why it's so important. Yield goal is built into this equation. Yield goal times 2.5 minus that soil test nitrogen. That's what STN stands for, and then our minus our credits there. So if we think about that yield goal, how do we get it? Well, it's yields from your own farm and your own fields. I recommend producers update their yield goals every year when they do their insurance work. Usually in the fall when they're summarizing all their yields and reporting it to their insurance company, or in February when they kind of select the levels of coverage that you're going to go with. So do it sometime in a pattern, and you get those, you got a record of those yields. So get those yields out and look at them. And then if you got a low one like here in 2012, just take it out, take what's left and average it. We get 76.4 bushels, and then take it times a factor. And that's our improvement factor, our efficiency improvement factor. I got 6% here. You can use whatever you want on your farm. I wouldn't go much higher than 6 or 7%, maybe 4 or 5 for wheat, but 81 bushel would be the yield goal. So remember, yield goal is the yield you can get, not the yield you want, okay? It's realistic for your farm. If you don't use this procedure, this equation doesn't work, okay? This equation is based on developing a good yield goal. So we'll leave it at that. I want to show you a couple studies that we did. There's actually 3 here: Crestbar, Gettysburg, and Bath. We had increasing nitrogen rates. You can see on the left-hand side here up to 200 pounds. We measured the nitrate in the soil to 2 feet. You can see those are relatively almost similar here across those 3 sites. And then we measured the yield. And you can see at Crestbar and Gettysburg, we had very, very poor yields. So in 2006, I think you recall, in some areas of our state, it was very, very dry. And so that is a drought response right there. We still had a response to nitrogen, believe it or not, 13 to 18 and 20 bushel. This is a response to nitrogen, as well as this 11 to 21. Very inefficient. When it's dry, the uptake of nitrogen is a very inefficient process. Okay, it takes more to get a yield increase. But just over at Bath, which is barely 40 miles east of Crestbar, it rained. And look at the response we got. 16 bushels in the check there, all the way up to 67 in that 200-pound rate. In fact, we saw no plateauing of yield at this site. So we don't know what the optimum or maximum yield would have been from nitrogen at this site. One neat thing that we did is we came back and we took soil samples from each one of these plots and measured the residual amount of nitrate that was left over. And you can see at the sites that were drouthy especially, that the amount of N left in the soil goes right up with this increasing nitrogen rate. So it's still there. In fact, at Crestbar, all of this N is in the top 18 inches because the soil was so dry, we could not get below 18 inches. It was just rock hard. And then over at Bath, despite our nitrogen increase, bushels, we still see a slight increase in N with increasing N rate. And so it's there. It's kind of like priming the pump, if you will. We excited those microbes with those higher nitrogen rates to break down carbon sources to release more N. And so that's kind of the fallacy of overshooting nitrogen rate is you're going to have some left over no matter what I think your yield goal is going to be. So I want to go into a few studies that we did, highlight the foliar application of nitrogen, timing of nitrogen. This one is a foliar project for optimum grain protein. I want you to hone in on the application timing in the middle. We had a check, a boot, and a post-pollination timing, winter and spring wheat. We broadcast nitrogen at planting for our yield portion at only a 50 bushel yield goal, purposely to kind of control that a little bit so that we would have some data that would be nitrogen starved, if you will, or nitrogen deficient, so that we could see the responses to our treatments more clearly. And we never know what that's going to be because the climate is the elephant in the room. It controls a lot of what we do, but still we can use good management to monitor this and decide what our rate should be. So one thing we saw is as grain yield goes up here on the x-axis, going up, grain protein comes down. And this red line is our 50 bushel yield goal. Okay, and so, you know, these lower yielding sites, there's plenty of N there and plenty of N to partition into that protein as well. So we had enough N to build the house, and we had enough N to put the furniture in the house. I kind of look at it that way. But down here, we barely had enough N. We got the house built, but we couldn't put anything in the house. So the protein is low. Okay, that's the general relationship. So we further want to determine just what application timing was the best for increasing or enhancing grain protein. It was that post-pollination timing, and I've shown you that here in this graph. I don't have the boot stage because it was non-significant, but here's the post-pollination time frame. And if we it's kind of hard, but this is relative grain yield, okay? And this is relative protein. And these yellow points represent a grain protein increase from foliar N when the grain yield goal was exceeded, because this side of 1, our grain yield goal was exceeded. The left side of 1, it wasn't. It was those lower yields. And then above 1 for protein is we enhanced protein with our foliar application, and below 1, we did not. So 70% of the time when we exceeded our yield goal and we put on a foliar application of nitrogen after pollination, we got a significant grain protein increase. So now I want to look at fertilizer source as an influence on grain protein. We have all this talk. Well, I'll put a little urea on at boot stage or maybe at heading. And then there was a debate whether it was the ammonium in the fertilizer source or the nitrate in the fertilizer source that was causing this. So we devised a little research project where we looked at liquid products. Basically, there's our standard UAN, urea ammonium nitrate. And then we made a liquid ammonium nitrate. We just dissolved ammonium nitrate fertilizer in water to mimic that dry AMN product over here. And then we made a dry UAN as well, where we just took urea in the correct proportion and ammonium nitrate in the correct proportion and made a dry UAN version of that. And so we use those products and we put them out, and the results are here. Of course, here's our check where we had no post nitrogen application above our nitrogen for yield. Okay, so we got about 15.3 protein, which is really good. I mean, why would you want to put any more, right? But if there's a little bit of a premium, this might mean something. Our dry products improve the grain protein, there's no doubt, about 3 to 4%. But our liquid products really are superior. And what we think is when we apply a liquid nitrogen fertilizer after pollination, that it is more readily absorbed into the plant more quickly. There's a quicker pathway. Where the dry fertilizers are falling on the ground, and you have to catch a quick rain to dissolve those and to get them into the plant quickly. Now, both those UAN dry and ammonium nitrate dries have nitrate. So if they dissolve and get to the roots, the plant should take them up real quickly, okay? They don't have to go through that nitrogen transformation that urea does. So there's enough ammonium and nitrate in those that they would get taken up quickly. But still the liquids were superior. Next, I want to look at a much bigger project that was done to expand on some previous work. Timing influence here on grain yield and protein. We had that nitrogen application timing. Now, this would be the nitrogen that you would apply for both your yield and protein, okay? So we applied 50 pounds of N at planting, tillering, jointing, boot, and heading on a couple different spring wheat varieties there. And we measured yield and protein. And what we see here is that the planting and tillering applications have the highest grain yield, about 70 bushels there. And as we wait and delay our nitrogen application, the yield is going down. At jointing, we've lost 5 bushels. And by boot, we've lost another 5 to 6 bushels. And by heading, we've lost, we're down in that 45 to 50 bushel range. But look what happened to grain protein. Grain protein is going up. And that's due to that low yielding wheat, okay? And the presence of that N too late in the growing season. We did that over a number of years. I just showed you the 2003 data because it made a really nice explanation of what was going on. But if I plot all of the years on a similar graph, I come up with a curve that looks almost exactly the same as that one year, 2003. However, in 2002, if I look down here in the corner, there's my planting and tillering and boot treatments. All of those yields are very low, and the protein is very high. Okay, that was somewhat of a more drier year where we were at. And 2001 is grouped up in here. It has the highest pre-nitrogen soil test. It has 146 pounds of nitrate in the soil when we put that out. So we wouldn't expect any response to anything, and we didn't get it. Okay, so just wanted to kind of show you the overall look at that. So lastly, I'd like to talk about a big project funded by the Wheat Commission. Lots of sites, had a graduate student. We really wanted to expand on our work, put out various rates of soil nitrogen across the soil, and then apply that foliar treatment, that liquid foliar treatment after pollinating, like we had learned was the most effective. And so we expanded that and into a much larger project. And then we wanted to also construct a decision aid that farmers could use for determining when to put on these foliar applications. And so the first concept would be, and that's the one I'm going to talk about today, would be that farmer would take a boot stage plant tissue sample, the whole plant at boot stage, get it to the lab and analyze it for nitrate N. Yep, in the plant. There's very small amounts of nitrate N in the plant, but they're there. And total nitrogen, which is the common measurement for nitrogen in plant tissue. Nitrate is not a common analysis for plant tissue, but we use it when there's droughts for toxicity to feeding livestock. And we just thought we'd use it here to see how it would relate to the responses we got. Then the second concept would be to use Green Seeker. And that was the graduate students part of this. And Anne published that in a thesis, and I'm not going to go into that today for time's sake. What we did is did it a number of years. Our spring wheat nitrogen rates were 0.75, 150, 225. Our winter wheat was in 50-pound increments there, jumping to 75. There you can see the older varieties we used. Our foliar nitrogen rate at post-pollination was 30 pounds. And we measured whole plant at boost stage and analyzed it for total N and nitrate N. Of course, we measured grain yield and protein. Here was the effect of N rate on grain yield for the spring wheat and the winter wheat. The spring wheat is the lower bars here. We had a nice increase in nitrogen with 75 pounds of N, but nothing beyond that. And we had a similar thing happen in the winter wheat, but it was only with 50 pounds of N here, and then nothing beyond that. Okay, so that was the effect of the soil applied nitrogen rate on grain yield. Now I'm going to look at the effect on grain protein of the post-pollination treatment. And so here we have those nitrogen rates again on the x-axis that were applied, at planting time on the soil for our yield goal. And then This is the treatment that got the same nitrogen rates applied to the soil, but we applied that foliar post-pollination treatment, 30 pounds in. And we increased protein at every level of soil applied nitrogen rate. We didn't expect that. We expected at some point that these lines would converge because of our reduced nitrogen response, yield response at these higher rates. We should have had enough nitrogen there. But at every nitrogen rate, we're increasing protein. And that's something we didn't expect to happen, but it did. It may have something to do with that efficiency of that liquid UAN applied so late in the season that it's being absorbed by the florets and the seeds themselves. And there's a big debate whether that's real or fake protein. And I'm not going to go into that today because still, all these years later, almost 20 years later, we still don't have a clarification on that. So I'm going to let it ride for today. Not going to discuss that. But when we look at our plant tissue nitrogen forms that we sampled for and relate that to protein in the plant, here's the total N that we sampled for. And of course, as you see total N increase here in the plant, grain protein is going up. That's a given, okay? That's going to happen. But I've plotted these two curves here where we have our check plot where we didn't apply the foliar N, and I have where we did. And what we want to see in soil fertility calibration work is the development of a sufficiency level. Is there a point where we can say, if you're higher than that, you shouldn't apply that foliar N for protein? So with total N, we can't say that because these are really just nice general curves going up. And we can't establish a sufficiency point. But we can with nitrate N at boot stage. It appears that it's somewhere in here about 0.1% nitrate N in the plant at boot stage. That maybe at this point, if you're below that, you should maybe consider making a foliar application of N for enhanced grain protein. Because these days, it's not really about trying to go for a premium in grain protein. We want to really first deal with the deductions that you might receive if you have lower protein. And I'm talking about that grain that's stuck in the bin that they don't want, that we'll call you when we have a need for your wheat. So we're trying to really avoid that first. And then, the premium is like frosting on the cake. So I think of it this way. The nitrate in the plant is more of the pipeline, the supply to the plant. It's kind of like maybe a gauge in that pipeline. If that nitrate in that plant is high, above that 0.1, then the supply is good. And if it's below, then we're running out, okay? And we probably have enough in the plant to build the house, but we don't have enough in the plant to put the furniture in the house. And so I think of it as a gauge in the pipeline. And of course, the total N measurement in the plant is like the tank. It's like the storage tank. We've been filling the tank, and now we're going to produce that head. And if we've got enough to grow the plant and make the head, but we don't have enough to develop the protein as that seed develops, then we're in trouble. So that's how I kind of think of the difference between the two. So I believe I'm getting close to the end. I would summarize that nitrogen fertilizer prices, have risen and fallen, and usually they're too high. And so, careful management is crucial to making money with wheat. Foliar nitrogen applications do enhance grain protein and should be made after pollination when you expect your grain yield to exceed your yield goal. So you've been farming a long time and raising wheat, and you're looking out there going, boy, that's the best wheat crop I've seen in a long time. Your gut intuition says you're probably going to exceed your yield goal, right? You could go out and measure. I'm all for that, but sometimes just our instinct is what we need to go on. So if you feel you're going to exceed what you planned for, consider maybe a post-pollination application of foliar nitrogen. Of course, look at premiums and deductions because they really influence, is this economical? Usually those deductions are much larger than the premiums. And application to enhance protein should be liquid fertilizers. I think I've established that point that late in the game, we need something that could get in the plant most quickly, and that would be the liquids. And applications for grain yield should be made before that tillering growth stage. You just wait too long, it just can't be effective. And then if you're going to do some plant stage sampling, we recommend that boot stage and analyze for nitrate N. And as well, get that total N done too. Contact me if you do that. I'll help you interpret that because most of the labs aren't ready to do nitrate N on a plant tissue sample. So please make sure you specify that when you send it to the lab, and then find my contact and we can talk about that. So with that, this is my contact. I'm done, and I think I've used my time. And thank you for giving me the opportunity to speak to you today.
Well, thanks a lot, Anthony, for that great talk. We do have a few questions in the chat. And again, we'll have more opportunity for questions at the end of the hour. So Anthony, if you can answer these few questions. So Tracy is asking, why does NDSU recommend to account for no-till credits for fields that have been in no-till for over 5 years?
Well, I know Dr. Franson quite well. I would consider him a mentor as well. He's been in soil fertility research many, many years. And he would say all fertility recommendations are local. And I would agree with that. And that's why we have an ag experiment station in each state. And so that's what he has found with his research in North Dakota. We found with corn that when you're transitioning to no-till, you need to add a little nitrogen. And then as your soils improve and mature in soil health, then that goes away. And Sarah Bowder's master's thesis kind of showed that. It did show that with longer term no-till. And so that's the differences. They're cooler in North Dakota. And so that's just the way that that research comes out.
Okay, so because of time, we'll reserve these questions for after the hour. So if you have more questions, please type them in the chat and we'll answer them at the end of the hour. We'll have more extended time for formal discussions. So we'll be transitioning here soon to the second talk on selecting the best wheat variety given by Dr. Kleinjan. Dr. Jonathan Kleinjan has been with the SDSU crop performing testing program for over 4 years, I believe. And he's also a grower himself, not far from here on Brookings campus. So great experience in farming and of course, variety selection. Dr. Kleinjan, if you're ready, I'll stop sharing this code and then you can upload your presentation.
Yes, thank you for the introduction, Emmanuel, and let me share this here. Is that showing up like it should?
Yes, looking great. Thank you.
Okay. Yeah, thanks again, Emmanuel, for the introduction. And like you said, I've been in charge of crop testing. Actually, Emmanuel, it's going on 7 years now. I don't know where the time goes, but so a little bit more than 4, but grew up in Brookings County on a diversified farm. And I still, as Emmanuel said, still farm on the side besides working here at SDSU. That's a good segue to the photo on my cover slide here. This is my uncle actually cutting spring wheat kind of near Lake Oakwood, and that was from this year. So my family still grows a fair amount of spring wheat in Brookings County, which I guess is unusual, but I've always been interested in wheat, and like Anthony said, the rotational benefits, the straw, a place to spread manure, and honestly just kind of nice to get some of your work done in the summertime rather than leave everything for the fall row crop harvest. So anyway, today I'm going to talk to you about wheat variety selection. As I mentioned, in charge of the crop variety trials, I see a lot of wheat and I've seen a lot of varieties over the last 7 years, and it's somewhat a little bit of a challenge to make this a long talk or a 30-minute variety selection, but you'll see that some of these do rise to the top, and I'll be somewhat brief today, but let's get going here. So the crop testing program here at SDSU does spring and winter wheat variety trials. I've put the links here on this slide. If you want to find them easily, just Google SDSU crop performance testing. That's the easiest way to find them. I suppose I could try to stick these in the chat, but I think most of you, if you're involved in wheat production, already know where to find these documents on the SDSU website, as there's really not much private testing of wheat, if any. So this year, due to COVID, we weren't allowed to have any wheat variety tours. Typically in the state, I go around and do about half a dozen winter wheat variety tours and spring wheat variety tours. We tried some different things this year. This is a shot of spring wheat at our Miller testing location. And we put some of these signs up with the SDSU extension logo, and then we're sponsored by the Wheat Commission, so we have their sticker on the sign too. And then I put handouts in a document box, so if people wanted to come and look at the varieties themselves, they could walk through the plots and kind of just see how things looked. In addition, we filmed some virtual tours. So here on the left, we had winter wheat variety trial tours. There's Dr. Sunish Segal, our winter wheat breeder. And on the right, we had spring wheat variety tour. These are still available on the website. So if you, like I said, if you Google that SDSU crop performance testing and find the crop testing sites, these YouTube videos are still posted, and you can walk through the varieties. We had these professionally done. They did a very nice job. And Emmanuel there speaking about disease. We had the spring wheat breeder as well in that video. So I think they're very nice videos. I'd like to continue doing this in the future. Maybe not every crop every year, but maybe spring wheat one year, winter wheat the next, oats the following. We'll see how that goes. So let's talk about winter wheat first. Here was our winter wheat yields from 2020. You can see we had very strong yields in the central part of the state, especially around that Pierre area, Hayes. We've actually had very good winter wheat yields in Hayes the last couple of years. Yields fell off a little bit. While we ran out of water. Martin, I suspect we had some dry weather there too. I never did get a good answer from the guys West River what really happened in Martin, but the gradient in the plots there was so severe that the data was really unusable there. Mount Vernon was disappointing. We had a windstorm go through there, and I'll share a little bit about that on the next slide. And then even South Shore and Brookings, really out of the winter wheat production belt, we had very strong yields there as well. And at Brookings, we do a fungicide and non-fungicide treated trial, and I'll talk a little bit about that in the slides to come, or a slide to come. So overall, I would say in 2020, we probably had the best winter wheat production year that I've seen since I started this job 7 years ago. So here's a picture of the Mount Vernon location. This, I believe, was taken around the 10th of June, or it was sometime in there. We had basically tornado force winds going through there. Here's a picture of our plots. You can see how severely lodged they were. And this probably shows up here. The field around it was planted to the variety of Oahe, and just kind of the perfect storm of lodging there. You know, we had the winds, but yet this was PP ground from the year before, and there was a lot of residual nitrogen, and then they basically poured the coals. I have honestly never seen a growth of winter wheat like that. You literally could not walk through it, even when it was still standing upright. It was so thick. But I guess the silver lining of this, when we see this kind of thing, it helps us evaluate which lines are better for lodging. So we did learn quite a bit here. Yields were, you know, like I said, disappointing. I think we had potential for 100, 110 bushel winter wheat here until that wind really knocked things over. But anyway, that just kind of shows you some things that can happen. in wheat production. Okay, moving on. If you go on the website and look at the different files, you'll see that there's one file that's usually at the top called the regional summaries. And what that is a summary of it's kind of a list of every variety that's tested along with agronomic and disease characteristics, and then a summary for each area of the state. And I summarize Eastern, Central, and Western South Dakota differently. The reason that I do individual locations is simply so that we can get the data up more quickly. So rather than having to wait for all the data to come in to do the regional summary files, I can get results up as soon as the individual location is harvested. And the individual trial sites have a 3-year history for each location and just some cultural data for each location tested. But really probably the most important document is going to be the regional summary. And this is the same for both winter wheat and spring wheat. So here's a example of the Eastern and Central summary. I didn't put Western on here. I just kind of wanted to show, and I didn't mean to omit Western, but I just didn't want to fit all three on one slide because I thought it got a little too busy. But you can see I sort everything by the 3-year average, and I started to use top third, I guess, rather than using the LSD to show significant differences, because I feel that kind of showed how things rose to the top just a little bit more. So how this works is, and we'll just talk about the Eastern summary here, is the varieties are sorted by 3-year yield first. And then if something has been tested for 2 years, it's sorted by the 2-year average yield after that. And then everything that is tested for 1 year, the yields are reported in the 2020 column over here. So I put a lot more weight towards what's been tested for 3 years. The reasoning for that is I've seen certain varieties do really well 1 year due to environmental or disease conditions. For example, 1 year Kleinjan, the first year we saw that, it was at the top of nearly every location. Colorado variety there, and I had producers call and say, where can I get some of that seed? I really want to plant that. And then since that first year, Kleinjan really has not done all that well. It's been average at best. So I would really recommend taking 1 year summary with a grain of salt, okay? 2 years better, 3 years probably the best of all. It is the best of all if you're going to look at things. And then over locations, that's why this summary file is so important. Some varieties will do better in certain parts of the state. For example, Monument tends to do better in the central and western part of the state versus the east. You can see Monument ranks a little bit higher here. Trying to think what else. Maturity has a lot to do with it. Disease resistance, you can see here Ideal has done well in the eastern and central part of the state in the last 3 years, but we haven't had any stripe rust. If we get a bad stripe rust year, Ideal just gets hammered. So that's why a 3-year average is a good thing to look at. And it's good to understand the varieties too, so you know what their weak points might be. Anything else I can point out here? The coefficient of variation down here at the bottom, most of you probably understand what the LSD means. It means that's the amount of bushels to tell if anything's really statistically different from one another. And the coefficient of variation is very important because you want a low number there. So if you get a number, I'd say when you get above 10, but more sort towards 15 or higher, that data is probably not the most trustworthy. So I like to see that in the single digits, the CV, and that tells you, for example, here in the 3-year, we have a CV of 6.8. That tells you that's pretty reliable data, okay? So just comparing Eastern and Central here, you can see some of these varieties float to the top. Winter, 4462, Draper. So there are similarities between regions. When you go to Western South Dakota, there's also going to be some similarities, but Western South Dakota tends to be slightly different than Eastern and Central. Today in this talk, I concentrate more on Central South Dakota because that's where the majority of our wheat acres are, and just for brevity's sake, over every region individually. Okay, this is a yield and protein biplot for 3 years of winter wheat tested in Central South Dakota. So if you go back, let me go back one page. If you look at the 3-year varieties tested over 3 years in Central South Dakota, This is a biplot of the grain yield as a percent of the mean times grain protein yield in pounds per acre. So this isn't percentage protein, but this is actual pounds of grain protein produced. So you take your bushel yield times 60 pounds per bushel, and then take that times your protein percentage. So protein is important in winter wheat, probably not so much as in spring wheat, but really what you want to be looking at planting is over here, anything with a greater than 100% grain yield average and a good protein producer. We'll talk more about protein once we get to spring wheat. But so anything in this kind of area is something that you probably want to look at planting, okay? So just to summarize there, my top picks for winter wheat, I'd say I get asked what the top 3, but I like to say the top 5. And this is for the 3-year average. Winter on the basis of yield alone and good protein content. And also WB 4462 from Westbred. Winter's a South Dakota release. All of these are very good yield and protein combinations. I kind of cheated here. I have 6. I have Ideal and Cy Monument. I do like Ideal. I have a hard time recommending it because it's so susceptible to stripe rust. So just be aware if you plant Ideal that if conditions are right for stripe rust, if we have a cooler year, you want to manage for that, okay? Cy Monument didn't really show up in that biplot up in that upper right corner, but I've seen Cy Monument enough to know that it's a very solid producer, and I would have no problem recommending that variety. And then I have an asterisk here for SD Andes. This is a new release from South Dakota as of last August. This one did very well in the eastern and eastern part of the state especially. Central it does very well, and actually it transfers pretty well to the western part of the state too. This is a double haploid, developed using double haploid technology. Probably the best lodging resistance that I've seen of just about anything in the trial. So looks to be a good variety. The reason there's an asterisk there, we have seen it for 3 years, but it was only available to foundation growers last fall. So it should be available to everyone this coming fall of 21 for planting. And then I always like to talk about promising varieties these are ones that I've seen for 2 years, and we have 2 from private industry, Cy Wolverine and WB 4595. Cy Wolverine's from AgriPro, and obviously the WB 4595 is from Westbred. So those 2 look really promising. Next year, this coming year, we'll have a 3-year average on both of those. So maybe those will displace some of these. We'll see how things go. There are some that typically look good over 1 year, but I don't really recommend those. Like I said earlier, because sometimes they're just one-hit wonders. Just do really well in 1 year and then average after that. Some new things in hard red winter wheat. This year we saw the first coaxium wheat. Basically, this is a tolerance to aggressor herbicide, quizalofop. I think this is a Sure 2, that family of herbicides. Aggressor, I think, is the one with the label for control in wheat. And this is a non-GMO trait, so it's a natural genetic modification, or not a natural, what's the word I'm looking for? A natural mutation, not modification. This was developed at Colorado State. And what this is, it's a tolerance to these aggressive herbicides, which helps with grass control. And you can see in this picture from a study, sorry, this is a little bit blurry, but on the right, we have untreated, and on the left, we have treated with the aggressive herbicide, and it really controls the feral rye. So this is going to be a good alternative to the Clearfield system if you have trouble with grassy weeds. And we've seen 5 varieties this year, AP18AX from Syngenta or AgriPro, 2 of them from Winfield Cropland varieties, Crescent AX from Colorado, and Helix AX from Lima Green. And actually, CP7017AX and Helix AX looked very good over 1 year. So I've never been really impressed with the Clearfield yields in the past, but it looks like these coaxium varieties are going to yield right up there with anything in the trial. So exciting new technology, keep an eye on. Other hard red winter wheat research I've done, fungicide. As I said, in Brookings, we do a treated and untreated, 6.5 ounces of sorrow flowering. We had about 9/10 of a bushel difference, so it wasn't enough to pay for the treatment. However, they were statistically significant. Some varieties we saw maybe a 3 to 4 bushel response to fungicide, but honestly, we just didn't have that much disease pressure in 2020. So we'll keep on monitoring that each year, do a fungicide and non-fungicide treated trial at Brookings. And then finally, seeding rate. Last year we looked at Thompson, the variety at 1.2 million seeds per acre and 1.4 million. Got about 6/10 of a bushel difference there. The higher seeding rate was better. However, these were not statistically different. So we can say any difference here was actually due to random chance or experimental error. So not enough data to prove that 1.4 million is going to be better than 1.2 million seeding rate. We're trying this again. We planted it again last 1.5 million and 1.2 million. So we'll have another year of data on that seeding rate study coming up. Okay, moving on to spring wheat. Here are spring wheat yields in South Dakota in 2020. Fairly good yields overall. Excellent spring wheat year in Brown County, also very good up in the northern part of the state. These are trial averages. A little disappointed in South Shore. Things didn't look very good there all year. I'm not quite sure what happened. Volga Brookings was very disappointing too. I think what happened here, we had a very warm, I guess I'd call it a hot weather wind blast for about 5 days right when this was starting to head out. So I think we really took the top end off our yields in Brookings due to that weather event. We lost the Draper location. Not sure what happened there, but the data wasn't very good. And then in Wall, the wheat yields were somewhat low there too, but we ran out of water in Wall. Okay, Sturgis, very good yields for the Sturgis area. Okay, when we get into spring wheat, as Anthony talked about, protein becomes, I guess, quite a bit more important. You can see here, this is not published in the variety trial results, but what I did here, this is a Central South Dakota trial. I listed everything that was tested except for the experimentals. And then they're sorted by overall yield. So we have how many times were they in the top third, test weight, protein, yield, and then revenue. And revenue is based off, I just took $6 spring wheat times the Ag Tegra curve for South Dakota. And that's how I come up with revenue. You can see this year in 2020, there's really not much of a premium to proteins. So they're just not paying for it. As you can see, the color code here for revenue matches yield pretty much exactly. So this year, the more yield you had, the more revenue you had. There's really not much of a premium for protein. Let's see, anything else I want to mention here? Not really. Okay, here's a biplot. Again, we saw this before in the winter wheat. This is for spring wheat. This is just for a single year in 2020. This red line represents 14% protein. Everything we had this year was above 14% protein. So as Anthony mentioned before, we're trying to keep everything above 14. We just don't want to get discounts. Actually, the last 3 years, we've had very good protein contents in the South Dakota crop testing. So we haven't seen any discounts really, as everything's been above 14%. You can see we have a few varieties that are down near 14%. But again, here we have grain yield as a percent of mean, and then grade protein yield, so pounds of protein per acre. So over here, LCS Trigger, probably fairly well known in South Dakota. This thing will produce starch like nobody's business. And then there's another one from Lima Grain that was new this year called Buster, that's of the same ilk as Trigger. This 3099A from Cropland, A stands for onless, also a very good starch producer. So I guess to play along with Anthony's reference, these guys are really good at building houses, but they don't really care about furniture. You get down over here, these guys are kind of like lazy when it comes to house building. They like a small house, but they like to pack it with furniture. What you really want to look for, I feel, is something kind of in this neck of the woods. It's hard to argue against plant and trigger just because we get so many bushels, and especially if there's not a protein premium. Let's look at the same graph over 2 years. So you can see some of the same names. Trigger again is way over here on the right. We have some new ones, Torgy and Murdoch kind of in this area. So you want to see something above average in yield and then also a good protein producer. And then over 3 years. Oh. Over 3 years, you see some of the same names kind of again, okay? Let me back up here. I wanted to point out something. So this one, and I'm just going to say a couple words about it. I don't want to say too much, but this is a new one that is up for potential release this fall, SD4873. And honestly, it's a very unique combination of yield and protein. So you can see here we're at about 109% of grain yield, and it also really kicks out the protein. And actually, it's performed better in 2019. It did even better. It would have been like way over here by itself. So we're excited about this one. Let's hope it hangs in for another year of testing, and we may have a really, really good release coming from South Dakota in the next, in sometime this fall. So to summarize, my top picks for spring wheat, Trigger. I will say Trigger, you want to manage for protein. Make sure you have a lot of nitrogen in the soil, and you might want to consider a foliar application of N, like Anthony discussed earlier, to make sure that you reach that minimum of 14% protein. We haven't had an issue with it the last couple of years in South Dakota, but I have seen this down in the 12s before, and you don't want to have that happen in spring wheat. 3530 Valda, 3530 is from Winfield to Cropland. Valda is a very good combination of yield and protein. All of these really are. 9719 from Westbred. Driver is the newest one from SDSU. I don't know if you remember, that did really well in 2020, yield and protein. When you look at the 3 years, it was down a little bit further and to the left, but I've seen Driver enough to know that that's a very good combination of yield and protein. And then over 2 years, Murdoch and Torgy from Minnesota. AP is from AP Murdoch's from AgriPro. So these look promising as well. I like to tell people to plant 65% of your acres to an established variety, and then maybe 35% to something new. Or if you want to try one of the 1 year wonders, I would maybe do even a little bit smaller percentage, but you know, that's up to each individual producer. So with that, we're butting right up against 11 o'clock. And that is all that I have for you. So if there's any questions on variety selection, as Anthony mentioned, nitrogen management is important. You can manage your nitrogen or your protein content quite a bit with variety selection as well, though. So just keep that in mind.
Thank you very much, Dr. Kleinjan, for that great presentation. So we have time for a few questions. So if you can type those questions in the chat or in the Q&A area, Anthony, Kleinjan, Dr. Kleinjan or Anthony would be happy to answer any of the questions you may have. So thanks for joining us today. At the end of the hour, we'll have time to continue formal discussions on wheat production, or any questions you may have to our presenters today or anyone on the panel. So hang on to continue the discussion. Join us again tomorrow for a presentation on marketing. So that will be given by Jack Davis. So should be also a great talk. We really appreciate you that you're joining these talks and learning about crop production. We'll be sending out a survey tomorrow to help us assess how to deliver information to you. So be on the lookout for an email from SDSU Extension asking your participation in a short survey about the best way to carry out the outreach. Also, there's a poll already going on now on the screen. So if you can respond to that, again, to help us know how to improve in delivering information to you. So we thank everybody for joining us today. Again, if there are questions, please type them in the chat. We also have time again at the end of the hour to continue the discussion. So please stay on if you have questions or if you'd like to continue the discussion. We have one question in the chat right now. It says from Nico, what about the use of plant growth regulator for controlling length of growth and hence lodging in relation to higher nitrogen levels and pushing yield? So Anthony or
John, want to take that, or what do you think?
I'm sorry, could you repeat that? I was reading something here.
Yeah, so the question is from Nico, and it is asking about the use of a plant growth regulator for controlling length growth and hence lodging in relation to higher nitrogen levels and pushing yield.
Well, I have not done any work in growth regulators. I've seen some work in the literature. So what I saw in the literature, there was really no response to plant growth regulator. And I really can't comment a whole lot more on it other than that. Anthony, I know you've done some in oats, but honestly, I don't know if any work's been done in wheat in South Dakota. Typically, we don't have to worry about such, that slide I showed with that lodging. I mean, that stuff was almost shoulder high on me. And so that probably would have benefited from a growth regulator. But typically, we just don't see those lush type of conditions like that.
So yeah, David Karki and I have done some growth regulator work on oats, and it works. However, we haven't seen a yield advantage in our rate studies, our nitrogen rate studies, where we've had the growth regulator does the yield get improved because of less lodging. And I don't think David would. I think I'm recalling that correctly. But what I've experienced, I've put it on triticale, which I know is not wheat; it's part wheat. And if that regulator shortens the plant up by 8-10 inches, and you still have a tall plant, if you're going to have a tall plant, then you shorten it up and you still have a tall plant, what have you really gained? And so I guess that's what's been going around in my mind, and I haven't figured that one out yet. So, but I do think it's really has some merit, and we need to consider that. So, good question.
Thank you. And I don't know if David Kaki is on, but perhaps he could also chime in or later on during the discussion. I am not seeing other questions come through.
Got a Q&A, Emmanuel, I think.
Oh, yes. What do you like to see for spring wheat final stand in 70 bushel environment? So perhaps this is for John.
Yeah, I just typed a response to it. I'd like to see at least 1.2 million plants, I guess, per acre.
Okay. Yeah, I've seen some publications also where they're in spring wheat where they're talking of 1.4 million seeds per acre. So I guess that would be around the range.
Yeah, there's a little bit of wiggle room there, but yeah, I'd say that, like you said, 1.2. I can't argue you're going to see much of a response to 1.2 to 1.4, but somewhere in there, yeah.
Okay. Other questions at this time? So as I mentioned, we'll continue the discussion. There are formal discussions on any topic in wheat production. So please stay on. You have an opportunity either to unmute and ask a question or comment during the discussions. So there will be plenty of time for us to do that. But this will end the formal presentation, formal discussions on today's talks. So join us again tomorrow for the talk on wheat marketing, and then we'll also have time for any other questions that you may have. So thanks again for joining us. Next week, we'll also have 4 presentations on field peas, sorghum, and polycropping. So join us next week as well. We appreciate you for participating in these webinars. So thanks again. And please stay on for the continued discussion about today's talks, as well as any other topics in wheat.